Okay. This is us, right? Let's see where we left off. If I remember, we were kind of scrambling right at the end. I was getting that text view to pop up on the screen, just saying, take that from how did the homework go in general? Easy?
Not me. Bakari.
Yeah, he said Bakari. He's still doing laundry. He skipped class today. He's, yeah.
I don't know whether it's crashing a lot.
It's crashing a lot.
Yeah, I don't know in my studio or me. My code is just like crashing. It's really bad for my computer. It's completely freeze. When you press the app player, it freeze. And it will tell you to close after.
And this is on your Mac? And yours is on a PC? Old or new?
Not that old.
So decent.
Yeah.
So it's not because your computer's too slow.
I think it eats up a lot more RAM. Only 6 gigs of RAM.
Well, 6 gigs of RAM should be okay-ish.
We were doing it the other day together, and his was like super slow, so I was wondering what was happening. And we like looked at his task manager, and it was shot on RAM. It was at like 98% half the time.
Oh, really?
Yeah.
Why don't you add more RAM? It's like $8 for RAM. Can't you just skip pizza once? I actually know the feeling. Can't skip pizza day. There's all sorts of other things you can give up.
And the thing that yesterday I make it work, but they say computer science people are going to say it's sloppy and hacking, so just make it work. It's work.
Oh, yours?
Yeah.
Well, I mean, that's better than nothing, I guess. I mean, RAM has to be pretty cheap for your laptop.
I'll have to look it up. Honestly, I have to look it up.
So you don't even know how much money it costs. It might be super cheap.
If I had to guess, an 8 gig stick's probably like 40
Yeah.
$40.
So just tell Abe that that's what you want for Christmas and you want it now.
I just built a new computer, actually.
Well, it's just his laptop, so this probably won't the old RAM probably won't work on this one. But
I built a gaming PC.
did he? He doesn't play any games.
He does.
Like what?
I don't know. Something different.
Like The Sims?
Somebody else.
Have you seen that video, the Minesweeper? It's like a YouTube video of it's like a live a Minesweeper movie. Yeah, I mean the real people, where they're just randomly digging in the dirt, like wait, don't do that. There could be a mine there. It's actually pretty funny. You should look it up sometime. Let's see. All right, so we have our add player screen here. We can put in some jersey numbers, add player, go back here. Okay, oh, so I just have it set up where every time I hit this button, it throws a text view on there right now. Okay, so what we're supposed to do for the homework is we're supposed to make this guy, at least initially, we'll make it different here in a few minutes, but make this guy be a list of all the people on our team. Okay, so we maybe want our text view to have like the jersey number, and then the skill level, maybe with a dash between them or something like that. Okay, so let's go to our let's do this. All right, right now on add player, when we add the button, we are setting our core guy equal to players. Now, really, it's this point right here that needs to add that picture, add that text view to our main screen, right? All right, so back here in our main activity, right now, whenever we add this player button, this is when we're creating a new text view. We're setting that text view's text to right now just blah. And then we're adding it to our player list. And what is our player list? Our player list is a linear layout. So if we want to have access to this guy, we need to if we want to have access to that player list from within the other screen, where do we need to put it? Where do we need to make it accessible to ourselves? In core. Yeah, we got to put it up in the singleton. So I'm in screen 1 here. We add players in screen 2. We want screen 1 to get updated from screen 2. So we need to have access to screen 1's linear layout. We're going to throw that up in core. All right, so what I'm going to do is I'm actually going to remove it from here. We'll go into core. And we'll make this guy static. All right, so now my player list lives in core. So back here in main activity, it's no longer this .player list, it's now core .player list. And then this code right here, the code to add somebody to that player list, won't live inside my add player button. It's going to live in the code that actually adds a player to that array list that we have stored inside of core. So we'll go back over to add player. This is where we actually add the player to our array list. So we're going to go ahead and we're going to create a new text view. We're going to set the text in that text view to p.getJerseyNumber concatenated with maybe a dash concatenated with p.getSkillLevel. And then we'll say core.playerList. Add that guy. So this is the code from over in add player. So after we've successfully added a player and put it in our global array list of players, we'll then go ahead and create a text view. And we will set the text of that text view to the player we just created's jersey number, followed by a hyphen, followed by his skill level. And then we'll add that view to our player list, which is our linear layout from the main screen that we are accessing through core. That makes sense? All right. What kind of animal is core here? Is it a singleton, right? Okay, what are singletons? It's a design pattern. What's the rule of thumb for a singleton? What are they? What's the little blurb for what's a singleton? Go ahead. Okay, so it's a good idea to keep things that need to be shared between multiple screens. More than 2 is probably the correct thing. In this case, we're cheating a little bit, but in actuality, we're kind of seeing the real use of this because we have our second screen who needs to talk back to the first screen. So the easiest way to do that is instead of returning an answer to this guy, we're manipulating something that belongs to this guy up here in core. All right, so this is actually a pretty good use of a singleton. Let's go ahead and run this. All right, so we'll go to add player. We'll say jersey number 1, skill level 4, add that player. So there's my player 1-4. Jersey number 2, skill level 2, add the player. There's my 2-2. We're just adding that view to our list. All right, so that was the homework assignment. Not too bad. Probably easier than many of you thought it was going to end up being. Maybe you didn't do it this way, but now that you see the solution, not too horrible. Okay. Now, realistically, we probably want our players to be a little bit more than just jersey number and skill level, right? You know, we kind of want maybe players to have a name and stuff like that. All right, so let's go ahead and let's expand upon our player. In order for a player to have a, just so this guy looks a little bit, actually, let's think about this. Maybe instead of, let's expand upon a player. We can practice objects a little bit. All right, so if I want my player to also have a first and last name, what am I going to need to modify in my code to do this? What are the different points of my project that I'm going to need to change in order to store 2 pieces of additional information associated with players? So we're working with this idea of model view controller, right? What's model view controller? MVC. What's the idea for that? It's our little blurb. I gotta start remembering to do the quiz thing, right? Seriously. What's model view controller? Go ahead.
I like the idea you want to keep your logic database separate from the interface.
Okay, so we got kind of three components to our program, right? We have our view, what things look like. We have our interface, the logic behind, so that's our activity code, the Java code. And then we have our model. Now we haven't talked a lot about our model, but the model is, he mentioned database. That's our representation of our data, is the model. Okay, so when we deal with players, what is our model for players in our code here? So if I show you our code list. So there's all of our Java files, and then here is our layout files. Where's our model? What's our model out of this list? You play video games, Tyler? Are you lying? What's up? The layout? Which layout? I mean, you're already wrong, but let's just see how wrong you can get. See, I'm just waking them up. What's our model here? I just connected dots a little bit. He mentioned database. I kind of said model is where we're storing our information about players. So what's our model here for how we store a player? I can see why you would say array list. Array list is our construct for storing a big collection of players. So I might say that our array list holds a bunch of models. Okay, a bunch of structures that hold players. This guy right here, our player class, this is our model for player. This is the guy that describes what a player is. Does that make sense? This is our model. We don't see this. There can be logic in here if we want to do some player-specific things. But in general, when you look at our code right now, this guy is all about storing pieces of information about players and retrieving pieces of information about players, right? That's what this guy's all about. So this is our model for players. So right now, a player holds two pieces of information. It holds jersey number and it holds skill level. If I want to hold more information about players, I need to start with expanding my model for player to hold more stuff. Okay? Now, we're talking about this in the context of this idea of model view controller, which one thing I maybe encourage you to do is don't get too caught up in these names. I'm kind of drilling you each class on, just so we can kind of keep it fresh in our mind. But as long as you understand the concept that we're kind of keeping the different parts of our program separate, I think that's the most important thing, because one thing hopefully most of us are running into here is we've expanded our focus a little bit. We've moved past. So what we've done since the midterm is we've started focusing more on objects. So we've introduced a player object, and we're going to start doing things with these player objects. Well, now we've thrown this into the context of an Android application. And this Android application starts throwing a couple of new things at us that aren't necessarily programming concepts as much as they are just the Android way of accomplishing things. Okay, so all of this layout crap is all Android specific. That's not really programming. That's kind of more like, what's the magic sauce to make an Android app look okay? All right, so that's why we're mainly using linear layouts and stuff. Just get the stuff on the screen. It's better than our console, but we're not really focusing on that. Okay, so we're going to call this guy our model as it relates to a modern graphical user interface application that follows the MVC rules, let's say. But in the Java world, this is just a class. It's an object that we use to represent, in this case, a player object. Okay, so this guy is going to hold the individual pieces of information about players. So right now our players are impersonal, right? We hold two pieces of information. And what are these guys up here called? What kind of animals are these guys? Fields. Fields. Okay, so all objects contain three things, right? They contain, well, can contain three things. They contain 0 or more fields. They contain at least one constructor. We don't necessarily have to write it. If we don't write a constructor that takes no parameters and does nothing is provided for us behind the scenes magically, just so the whole new, so if we didn't write this constructor here, if we omitted that, a constructor that was called player that took no parameters would magically exist for us. So we would be able to create a player by saying player P equals new player open close parentheses. It exists so that syntax works. Okay, a little bit more to it than that because there's some lines that are magically missing here that Java hides things from us. And so there's a couple of lines here that are missing. If we saw this in a different language, we might say, like Objective-C is a language I like looking at for this. We might see the very first line here might say, this is equal to super.init, something like that. And then the last thing here is we're going to return this. So these two lines are kind of assumed to be there, or the equivalent of these. So when we create the this variable, in Java, this just exists. It comes with it. They do the magic for us to have this variable called this. And what's the variable this do? What's the purpose of that variable? Okay, it's how an object refers to itself from within itself. So this is to player as I might say me or I. Okay, when I'm talking about myself. All right. So, and I've only briefly introduced super, but what's super? Go ahead.
Super refers to the class that class comes from.
Okay, so the instance of your parent, right? Okay, who's this guy's parent? There's another little hidden line up here. So if we don't provide a parent, because we haven't really dealt with inheritance yet, we will here in the next couple of days actually. But if we don't provide a parent, who is this guy's parent? Go ahead. Not, well, Java's a language, so not Java. I think we're heading in the right direction. Remember when we first talked about objects, we drew a little hierarchy of objects, and who's at the very top of that hierarchy? Just make sure I'm not making crap up. Here's my keynote. I draw my picture somewhere. Well, it doesn't look like I did. Really thought I did. So we have our player object here. And in Java, all objects come from the global parent object called object. So Java comes with an object class built into it. Okay, and this guy is a representation of what the most generic object is. All right, so inside of the object class is going to be that code that generates the value for this. Okay, all that stuff. All right, so when we create player, a player automatically extends object. So there's a hidden line here, extends object, that we don't see. So all objects at the very least extend the top level object in Java called object. Now, what we might end up doing here is we might say, well, really all players are humans. So this is where we start talking about having first and last names, that kind of stuff. Okay, so if a player is a human is an object. So now we have 3 levels in our hierarchy here. So we might say, okay, well, players differentiate themselves from humans by having jersey numbers and skill levels in our world, right? Okay, now all humans have a first name and a last name. It's mostly true. I think there's some societies that don't do that, but let's just roll with that. Okay, so all humans have a first name and a last name and probably have an age, something like that. All right, so we might go ahead and we might define a class called human that says here are the fields, here are the attributes common to all humans. And then here's a specialized human called player. And a player is everything that a human is, but they're a little bit more. Does that make sense? So what we're going to do is we're going to expand player by introducing a new class that we're going to name human. And then we're going to make player extend human. So what we're doing is we're introducing the concept of inheritance. So we can just throw it here. So this is inheritance. Oh, almost spelled it right. All right, and this is no different than real life when we inherit traits from our parents and things like that. You know, we have things that are unique to us, and then we have things that we got from our parents and from our grandparents and from our great-grandparents and so on and so forth. Things are passed down kind of genetically. Same thing is true here. All right, so we'll go back in here to Android Studio. And I'm going to create a new model. Okay, I'm going to call it a model. So model is the MVC term for an object here. Okay. Eventually, when we start storing our stuff in a database, that model is going to be linked to a remote data source. It'll be stored someplace else. And we'll probably talk about that next semester when we actually start storing it outside of the application. But for right now, we'll roll with this. All right, so we're going to create a Java class here called human. Okay, and we're going to say that all humans have a first name and a last name. Let's keep it simple. We can say they have an age too, but I don't want to have to read in too many different things. All right, so we're going to say they have a first name and a last name. So we're going to say that humans have a private string F name. They have a private string L name. Let's spell it out. First underscore name, last underscore name. Then we have a public constructor for human. And this guy's going to take in a string first name and a string last name. We'll set this dot first name to first name and this dot last name to last name. All right, and then let's go ahead and give ourselves our getters and setters for these dudes. All right, so there's our human model. This here. All right, so all humans have a first and last name. These are 2 private fields, which means we can only access them inside of the class called human. So we went ahead and gave ourselves getters and setters to access those guys and change those guys if we wanted to, blah, blah, blah. All right, so now we're going to say that a player doesn't directly extend object. Instead, a player is actually a human. It's one of these guys. Okay? Now, I'm going to get rid of these 2 broken lines here. All right, now, since this is our, this error will go away shortly. All right, so because we're building a player in terms of a human, we really need to take in some additional information about our players. we need to take in the information about the player's first name and the player's last name. Because now a player is more than just a jersey number and a skill level. They're a first name, a last name, a jersey number, and a skill level. But the first name and last name aspect of a player, that functionality came from the player's parent, which is human. All right? So we're going to go ahead, we're going to take in a string first name and a string last name here for our player. And then what we're going to do, the very first line in our constructor, and if we choose to do this, it has to be the very first line. We're going to call upon our parent's constructor and have it do the initial setup for our player. Because the constructor for human knows how to set the first name and last name for all humans. So you look here at human, here's our constructor. This guy takes in a first name and a last name. Okay? So we're going to say super, first name, last name. All right, and we see it stop screaming. So what we're doing here is we're saying, I have a parent that has a constructor that takes two strings. The first string is the first name, the second string is the last name. So I'm going to go ahead and pass those two parameters that came in here. I'm going to pass the buck to my parent. All right, and it's my parent that knows how to initialize the first name and the last name. That make sense? All right, so we'll let our parent initialize the first name and the last name there. And then we'll go ahead and let the player further differentiate a player from a human by setting the jersey number and the skill level. Sound good? Kind of following what we're doing here? So one of the purposes of object-oriented programming is to minimize the amount of code we duplicate, have to rewrite. So we could certainly have a human class that has a first name and last name, and then we can have a player class that has a first name, a last name, a jersey number, and a skill level. And really what we've done there is we've written the same logic twice. The logic to control a first name and a last name for human, and the logic of controlling a first name and last name in player. Now that's okay, and actually by today's standards, where memory isn't really an issue anymore and that kind of stuff, it's maybe not the end of the world. In fact, in some cases, we might decide not to create the inheritance model just to create it. In this case, we could say it's technically correct to have a human, which then becomes a player. All right, it's technically correct. But if our whole application revolves around just player objects, and we never actually work with humans, or we don't actually have another subspecies of human other than players, if we only ever have players, we might as well just throw first and last name into player and move on with life, rather than actually create the inheritance structure. That makes sense? But we're trying to learn about inheritance, so we're going to do it this way. All right. And then maybe we'll force the issue here. As we keep evolving this application, maybe we'll have a secondary human that's like a manager. Okay, and managers maybe can be players, but they can also be, maybe they have other skill sets other than just what a player has. A manager also has a salary or something like that. Okay, so this is our player class that extends our human class, and we leverage our human constructor by passing that constructor the two strings that he expects. So here's our human constructor. Here's the first string, here's the second string. So he's taking in two strings. And this guy goes ahead and sets these two variables. All right, now, one issue we're going to have here is, let's say that after we've gone ahead and we've initialized our first name and last name using the constructor here, let's say that I want to modify my first name a little bit. Maybe I want my first name to be, we'll add an LOL to the end of it, just because. So I might want to say this dot first name is equal to this dot first name concatenated with LOL. All right, so right off the bat, we see that this guy is not a fan. Why is that? Why can we not access, player is a human. It extends human. So we have this thing called an ISA relationship in object-oriented programming. It's just a made-up term. Okay, a player is a human. A human is a object. Okay, so our player here is a human. Yet, as a player, I can't access my first name directly, and similarly, I'm not going to be able to access my last name. When you're doing your football stuff, Tyler, you have a jersey number, right? Okay, and in your head, you have a skill level. People don't necessarily assign it to you, but absolute value of a negative number. All right, so you have a skill level, but now you also have a name, right? Okay, now do you have to go into some room somewhere and meditate to, get to your human ancestry in order to come up with your name, or you just know your name, right? It's a convenience, right? It's a convenience. Now, why don't we have access to our first name here? Here's the definition of our human class. This is not new material. This is connecting some dots with stuff you already know. Why can't a player access first name? Because it's private. What does it mean for it to be private? We can only access this variable because it's private. We can only access it inside of the class name human. Now, I'm trying to access it inside of the class name player. Now, the player is a human, but we're inside the player class here. That make sense? All right. Now, do you think that it would make sense for players to be able to directly access their first and last name? Makes sense. So we probably have a mechanism for allowing that. I've actually referenced it before and kind of said we're not going to talk about this yet. So over here in human, we're going to loosen the reins a little bit. Remember I said that we should make everything private and then loosen the reins as necessary? So what we're going to do is we're going to change these guys to protected. Okay, protected means we have access to these guys within this class name human and also children of the human class. So now when we go back to player, it's cool with this now. Make sense? Now, let's just say that I chose not to do that. And I do want to modify my first name here. How would I pull that off? I want to add LOL to my first name. Here's my definition of human. Okay, who's set first name? So you want to use our constructor, or our getters and setters, right? Okay, so she wants to use the getters and setters. So now these guys are public methods that belong to a human, right? So I want to change my first name here. I could say super, which is my instance of my parent, right? Dot set first name to super dot get first name concatenated with LOL. So I could have done that. Now, I could have also said, let's do it for last name here. This dot set last name Could have done that as well. These are almost equivalent. Almost. The final result is equivalent. Okay? But these are not identical to each other. And the first clue should have been that super and this are different values. Okay? If we were to print out super and we were to print out this, we would see different memory addresses. We'd have a weird looking memory address for super that had the word human in it. We'd have a weird looking memory address for this that had the word player in it. Okay? Why am I allowed to do both of these? So this is giving us some information about how inheritance works. Here in human, all of those guys here are public. What does public mean? Everywhere, yeah. As far as we're concerned, they're accessible everywhere, right? Okay, so is inside the player class, is that considered everywhere? Does that fall into the category of everywhere? All right, so when we're in here, I should be able to access those. So I was able to say super dot set first name. I could access that public method. But now I was also able to use that public method directly as if I owned it. So if I'm a player, I could ask my parent class to call his set first name. But I could also just rely on myself to set my first name. Even though first name is a private, well, right now is a private variable inside of the parent class. Why do you suspect that is? When a player extends human, he gets all of the non-private members of human. Comes with it. Make sense? As a player, I get all that stuff. I inherited all that stuff. All right. I got my dad's eyes, but not his hairdo. It's like almost 70, and he still had full head of hair. This is going to be gone next week. This is a lost cause. This is what we're really dealing with here. All right, so we inherit stuff, and then we could always change it. So, for instance, I inherited the genetics from my father dealing with his hair. And then there was a twist, right? Okay, the Mike Lippman model did a little zigs and zags on his full head of hair. So that's just the way it works. All right, but we chose here not to redefine those things. Okay, so when we said we're going to build our player in terms of a human, we went ahead and said, hey, we're just going to go ahead and take those getters and setters that you provided. They were public methods. You have no right to them, right? Okay, if you wanted to keep them to yourselves, you would have made them private. So we'll just go ahead and take those guys, and now I can use them as if they're my own. Okay, no harm, no foul. Now, what is a little weird here is that as of right now, a player cannot directly change his first name and last name because those are private members of human. But a player can indirectly change his first and last name by using something he owns, by using these getters and setters. It's almost like a weird caveat. Like, I received the tool for changing my first and last name, but I don't know what my first and last name, what those guys are. So this is almost like a weird side effect to how object-oriented programming might work. So this is probably not something we would normally run into. We would normally say that players have first names and last names because they are humans. They also have a jersey number and a skill set. With that in mind, we would loosen the reins here and make these guys protected, therefore giving direct access to those variables to children of the human class, but not to just everybody. That make sense? All right. So a player now has a get and a set first name and a get and a set last name that it inherited from its parent, and those are public methods. So those pass through to the rest of the world. Not only do players inherit that because it came from their parent, but they're also able to now provide that to the rest of the world. So if I'm out here in add player, I can say p dot set first name. I can access that public constructor that actually came, or public setter that came from human, was passed on to player, and now is available to me here as a public method for setting those protected fields. First name and last name are protected. That makes sense? All right. Okay, now we're all memorizing all this, right? It's a lot of information, but it's all very related information. And it's important information, but good news is I'm not done. Because we're gonna throw more information in here. All right. Now, before we do anything else, let's go ahead and give ourselves the ability to get a first and a last name from for our player. So now I've expanded my player model to be able to accept a first and last name. Well, not just be able to accept, it requires a first and last name to create a player. So my player, this constructor, is no longer a legit constructor. I rewrote it. I changed the constructor. It now requires a first name, a last name, a jersey number, and a skill level. I'm only giving it 2 of those values right now. So we're going to go ahead into our add player XML, and let's go ahead and get a first name and a last name edit text in here. Okay, so we'll go ahead and we'll grab a edit text. And let's see, do we have a... No, I think we're just going with a plain edit text. So just to make it easy to drop this stuff in here, I'm going to go ahead and I'm going to drop it right there. And then I'm going to drop it right there. And then we're going to go ahead and update that guy so they look right. So we're going to click on that. We will make it centered. We're going to set the hint for this guy to be first name. We'll set the text to be nothing. And then let's set the, if I can actually click up here, there we go. Let's set the name of this guy to first name ET. All right, then we'll make this guy, we'll call this guy last name ET. Get rid of the text, set the hint to last name, and then let's center it. All right, so now our input form is able to accept 2 new pieces of information, but now I need to take those 2 new pieces of information into consideration and use it to build my player. So let's go back into add player activity. Up top here, we have our couple of edit texts. So we're going to go ahead and create 2 new edit texts for our first and our last name. So we'll have private edit text, first name ET, private edit text, last name ET. And let's go ahead and connect those guys here. So this dot first name ET is equal to the edit text version of this dot find view by ID r dot ID dot first name ET. This dot last name ET is equal to the edit text version of this dot find view by ID r dot ID dot last name ET. So now I give myself programmatic access to those 2 edit text widgets on our view. All right. Now down here we had some error checking stuff, right? So we can change this, well, let's just write it here. So we can say else if this dot first name et dot get text dot toString dot length is equal to 0. This dot error tv dot set text. You must enter a first name. Else if this dot last name et dot get text dot toString dot length is equal to 0. This dot error tv dot set text. You must enter a last name. All right. We didn't have to error check it if we didn't want to, but stay consistent. So we went ahead and error checked those guys. Make sure they put something in there so all players have a first and a last name. All right, so now we went ahead and got our jersey number from those two guys. So let's go ahead and grab our first and our last name. So we'll say string first name is equal to this dot first name et dot get text dot toString. String last name is equal to this dot last name et dot get text dot toString. And then in here we now have all those two variables, so we have first name and we have last name. So we're passing two additional pieces of information to our player constructor, which now makes it compatible with our actual player constructor here, which is expecting those two additional pieces of information. Okay. And then we're utilizing our parents constructor to go ahead and do a partial setup for our player. So if we want to use our parents constructor, we don't have to, but if we want to, it has to be the very first thing that happens inside of our constructor. All right, so we replace the name of our parent with the word super, and then we pass it the necessary parameters for that constructor. Our parent is human. His constructor takes two strings, so I'm passing it two strings. Make sense? And that will do the initial setup for the human side of player. Then we'll continue to set up our player here. And then this was just test stuff. Okay. Now a player knows about more things than just a jersey number and a skill set. They also have a first and last name, which means here in add, where's my add? Oh, there we go. When we set the text for this guy, we can go ahead and get that player's first and last name as part of the text. So we can say p dot get first name concatenated with a space concatenated with p dot get last name concatenated with I don't know, maybe an arrow concatenated with the jersey number and the skill level, something like that. All right, so we expand upon our player just a little bit, be a little bit more personal, I suppose. All right, so let's go ahead and run this guy. Now notice we didn't have to change our array list at all. Our array list already knew how to hold players. We just redefined what a player is a little bit. We expanded what a player is. Okay? A player is still a player, it's just a little bit more than it used to be. All right, so here's our initial list of things here. We'll click on Add Player. We'll put in Mike Littman, jersey number 1, skill level. It's got to be a number, so infinity is going to be tough. So we'll say Add Player, and there's our information about that player. All right, we can add more players. Put my brother in here. Skill level 2. All right, so we can add multiple players there. All right, that makes sense? How we're using the inheritance model to do that? All right, so now, in our world right now, I mentioned a few minutes ago I was going to even add more. So there's a lot of information about object-oriented programming we're compressing into this one lecture. Hopefully, it's not too hard to initially wrap our mind around because it's not a foreign subject to us, right? Inheritance is something that exists in real life. Okay, we just kind of have to wrap our minds around the Java way of pulling some of those things off. Okay, and that's just going to take time of messing with it and that kind of stuff. I actually had an interesting conversation about programming. We might try to do this starting next semester. Actually, let me get your opinion on this a little bit. How many of you do you think would have benefited in 200 to, instead of Alice, having a syntax-based language but something less complex to Java? Would that have kind of given you a better like jump start into the Java as opposed to no coding, no coding, no coding, boom? Good.
Honestly, if you started out with Zabbix, 200, I think that would help a lot.
Well, and we're going to start doing that. Yeah, that's part of our ABET accreditation stuff. So yeah, I agree with that. But the language we're looking at using, and it would also benefit you in industry too, because it's a skill set that a lot of people want, is starting with Python in 200. So Python is one of the problems with Java, and I mean, it's hopefully you've maybe kind of seen it, is the whole first half of the semester and the last half of last semester introducing Java, even though it's an object-oriented language, we haven't actually started doing objects till now, right? We just recently even thought about objects. Up to this point, we've been trying to use Java as this procedural language that it's not. So in order to do Java procedurally, where you have a lot of output to the screen and reading stuff in from the user, it's kind of a headache because it's not really what Java was designed for. It has those abilities, but you kind of have to force Java to do that. Where Python, you can get to those procedural activities, you know, writing stuff to the screen, writing stuff to the screen is easy enough in Java, but reading stuff in from the user, that kind of stuff, you can get there immediately without importing scanners and all this other stuff. So it gives you that initial feel of syntax without having to kind of dumb Java down a little bit. So I think that might be a direction we look at going next semester. But then that kind of conflicts with this idea of the Zybook, which is introducing Java. So we might look at something similar to the Zybook for more of a Python thing. I don't think Zybook specifically has a Python. I'll have to look, but something along those lines. Plus, Python is a pretty popular language. Are any of you doing internships or anything where Python is being used at work? I mean, it's popular. So it would be a skill set that wouldn't be a waste, where I would assume that not a whole lot of you are going to run into situations where Alice is going to come in handy, right?
You'd be surprised.
You would be surprised. Actually, Alice would probably play out pretty well at a hackathon if you didn't mention that you used Alice to make it, because you would be able to create something that looks pretty. I mean, hackathons are all about appearance, right? So it would be something that looks kind of visually cool. They'll just, oh, they did that in 24 hours. Like, it's basically make a video game. It's like, yeah, man, that's like no code. All that's just random numbers. It's just it's going around in circles. All right, yeah. So, anyways, what I was getting at there is I had it's a very interesting lunch I had yesterday with a Jesuit priest. So a former Jew walks into a bar with a Jesuit priest, and we talked about Lutheranism. Yeah, so he's going to be we're doing an assessment in the department this year, I guess, so this semester and next semester. So we need an external set of eyes that comes in. So this guy is a professor at Marquette, but he's a Jesuit priest. So, it was a very interesting conversation. So imagine like sitting down with your pastor, but talking about computer science stuff. But the guy's also, he's German, but sounds Russian, and lived in Uruguay. How do you say it? Uruguay?
Yeah.
Uruguay. Lived in Uruguay and Chile, I think. Chile. It was the weirdest lunch I've had in a while, but free lunch. Love free lunch. Because the professors there, if you're one of the Jesuit priests, they have their own dorm. You live there. I went in. There was like a receptionist and everything, but I got to eat their free lunch. Love free lunch.
was a good free lunch.
Yeah, oh, well, it's got to be a pretty bad lunch to not be a good free lunch. I mean, you know what? I mean, you're students. I mean, that's got to be a bad free lunch. All right, so last couple minutes here before I give you an incredibly impossible homework assignment over Thanksgiving break. I'm not going to give you homework over break. We got to pay attention to the last 7 minutes. All right, so in our program right now, not that we wouldn't necessarily ever do this, but in our program right now, we're never actually going to create instances of humans, right? The only reason this human class exists is to support the concept of inheritance, right? We only created it for that reason. We're never actually going to create humans. We're going to create players who are humans. Now, with that in mind, we have a keyword to introduce here called abstract. Now, these words transcend Java. So abstract is a concept. Not every language uses this exact same word. Many do. But it's similar to like the this keyword. So the this keyword transcends Java. It's an object-oriented concept. Java uses this. C# uses this. C++ uses this. Objective-C uses self. Swift uses self. Visual Basic uses me. Those are all the same concept with just a couple little deviations. Python uses self when you go to do the object-oriented stuff on Python. But in any case, abstract is a modifier on a class, technically on a class member, but typically we're going to think about this for the class itself. A modifier on a class member that marks the member as existing for the purpose of inheritance only. And if we were to give one sentence, we might say that abstract classes cannot be instantiated. Right now, as we have the human class written, we can say human H equals new human Mike Littman. That's allowed. Okay, because it's a normal plain Jane class, just like our player class is. And if it made sense for us to have humans, we could, right? No problem. But, like we just discussed, in our world right now, in our little soccer team management dealy flippy thing, we're never actually going to have humans. Everything's just a player. Humans only exist to kind of support the organization of player. So we can say humans have this, players, this is what's special about players. We're kind of teaching inheritance here, so that's why it exists. Okay? So what we can do here, and let me start off by kind of faking it. So I'm going to go into add player activity. And let's see, where are we at? Creating our player. Here's our player we're creating right here. So I'm going to go ahead and right underneath this guy, I'm going to create a human H is equal to a new human, and we'll just use our first name and last name again. All right, so this line right here. That's perfectly legal. Nothing prohibits us from creating an instance of human. That's what I mean by instantiating the class. I am instantiating the human class here and storing the pointer to that instance inside of a variable called H. All right, this is allowed right now. But if I go into human and I say, you know what? This guy is not a class that I ever want to create an instance of. I'm going to make that an abstract class. By making that guy an abstract class, notice here in add player, I am not allowed to create a human. All It's like another level of protection. So like we have the public, private, protected stuff. Now we also have abstract, where we're kind of locking down a class. We're just saying, look, you don't want to create these guys. They're basically empty husks, right? You can't do stuff with just humans. We need players to actually do stuff. Humans are just the construct. That make sense? I mean, I do it, but like usually you wouldn't just eat straight peanut butter. You need peanut butter plus jelly plus bread in order to have a peanut butter and jelly, and that's edible, right?
You eat just peanut butter.
Well, I know I do because I'm low carb. That's the only kind of dessert I can eat. I get the ones, the super chunky ones.
Yeah.
Oh, love that. And you know, they say 2 tablespoons is like 3 carbs or something. So I get this giant like a serving ladle. Figure that's 2 tablespoons. So I do a heaping ladle of peanut butter, and I just eat it right out of the ladle. My wife calls me an animal. Then I usually get another timeout because sometimes I drop the ladle on the floor and I pick it up and keep eating, but now there's like a smear of peanut butter. It's bad. All right. So we get the concept of abstract. All right. You never have to use abstract. You never have to use public, private, protected. You know, it's one of those things that's there for us to self-police. We should use it. It's good programming practice to make things that we don't need to access outside of the class private. That way we contain the number of weak points, right? But you could just make everything public if you wanted to and just never write a getter or setter, and you could still be a effective programmer. You're just not writing, you're not following good programming practice, and you're probably making your code difficult for other people to use. Because by putting getters and setters in, you're defining the way you want other developers to access your objects. That make sense? All right, so I'll go ahead and delete this guy for right now since he's currently illegal. No homework over break. We will come back next Tuesday and we're going to talk about, actually we won't talk about interfaces yet, but we'll add some more features to this guy. And I will see you then. If you're traveling, have a safe trip. Remember, student, faculty, staff Bible study today. You get free lunch, and apparently it's Thanksgiving dinner lunch, so you get the turkey, the fixins, all that crap, so you go get that for free, and then go and have a Bible study. God and grub. Can't beat it.
Can we make an appointment after Thanksgiving?
Sure.